So, welcome to this new lecture, and in today's lecture we are going to discuss about allowed configuration. And in previous lecture you have got an overall picture about the configuration space. Okay, so what do you mean by allowed configuration? Okay, let us understand this. You know what is configuration space? What is configuration space? Nothing but a set of the position vectors, like you are writing r1 vector t, r2 vector t, okay, rn vector t. Okay, so this is the set, and this set you are calling, you are defining as the configuration space. If and you, in previous lecture I have told you, this will satisfy the constant equation. It will satisfy constant equation. If it is satisfying constant equation, so what is constant equation? Constant equation is nothing but holonomic. So you can write as f of r1 vector t, r2 vector t, and definitely rn vector t equal to 0. Okay, very nice. Okay, if it is satisfying the constraint equation and it is containing the time part also, okay, so it is rheonomous holonomic. So what is this? Rheonomous holonomic. Okay, holonomic. So this rheonomous holonomic constant is now, it is defined, it is called as allowed configuration. That means when a particular configuration will satisfy this condition, that is rheonomous holonomic, if it will satisfy the rheonomous holonomic condition, that configuration is allowed configuration. So you can write the definition also. When a configuration satisfy rheonomous holonomic condition, then that configuration is called allowed configuration. That means if you are having configuration space, whether it is allowed configuration or not, how we can check it? Simply you have to find the constraint equation, and you know the constraint equation, that is holonomic constraint equation. If it is containing time, then it is rheonomous holonomic, and that particular configuration is called as allowed configuration. In most of the cases you will get the allowed configuration, because in most of the cases the constraint equation is holonomic. I have already mentioned it. Okay, so this is allowed configuration. Okay, so if it is satisfying the constraint equation, what are the troubles in constraint equation or constraint? The coordinates are no longer independent, so there is no, you cannot choose the value as per your choice. Okay, so the value are fixed. If you are taking the value of x, y is fixed. If you are taking the value of y, x is fixed. That means coordinates are no longer independent, like you are having y is equal to x square plus 1, where x is independent but y depends on the x. Okay, but now when you are having constant equation, coordinates are no longer independent, and we have understood it very well by considering some beautiful example in abacus beads and some moment like in a square. Okay, and now we will going to discuss one of the most interesting and very confusing also, that is virtual displacement. Okay, so you know what is virtual? Anything which is not real. Okay, anything which is not real is known as virtual. You heard about the real displacement. If I am having a point here, if I want to go to this point, then what is the displacement? I am not talking about the distance, I am talking about the displacement. This is the displacement. Okay, if here it is the time t, then definitely you will take some time. Okay, I don't know how much time, but you will take some time, and that time is t prime. Okay, that means when a particle will change its position, how it is changing its position? First it was at point A, the position was here. When the particle goes to point B, the position is here. that means the particle is changing its position, okay, here to here, changing its position. This is the particle. First it was in this position, then it moves to this position, then the position changes. Now the position, new position is here. It requires some time, okay. For example, you are going to a shop to buy some potato, so the change in position requires time, okay. It will take some time. Suppose it is 12:45, 1 second, you will go to the potato shop, it will take, suppose for example it is taking 3 seconds, so you require some time to go to that point. But in case of virtual displacement, there is no time elapse, that means there is no change in the time. Suppose if you are in 12:45 in this point, in potato shop also you are in 12:45, that means you are changing your position, but the time is constant, time is not changing. Are you getting my point? The time is not changing, or it is not consuming any time. So how is it possible? How we can visualize it? So it is very much difficult to visualize it, but we can feel it. This is the virtual displacement, okay. This is called virtual displacement. We can take another example to understand this. If I am having a coaxial cable, okay, coaxial cable, okay, suppose this is the point, this is the particle sitting at point A, and if we want to go to point B, and this is nothing but your radius, and I am taking this as A and I am taking this as B, okay. If the particle is undergoing an infinitesimal change, what is infinitesimal? Infinitesimal is very, very small, okay. Infinitesimal change, infinitesimal, okay. So check the spelling, infinitesimal, infinitesimal change, okay. So if a particle is undergoing an infinitesimal change from this point to this point, if there is no elapse of time, that means time difference is equal to 0, then that displacement is known as virtual displacement. You have to get my point, okay. If I will write this equation, okay, so what is happening if the particle is at point A and there is a infinitesimal change, okay, it is going to the point B. If it is going to the point B, so my question is, here the time is t and here also time will be t. The time will not change, it will not increase, and definitely you know the time does not decrease also. So it will not increase, okay, because it is very small change. In that particular small change, there is no change in time, okay, very small, okay, very small, for which there is no change in time. If here it is time t, if here it is time t, in this position also time will be t. Are you getting my point? If here it is 12:45 in your home and you are at potato shop, then the time will be at 12:45. That means you are being displaced. You are being displaced, but time has not changed. That means the time difference is equal to 0. So here the time difference is equal to 0. Are you getting my point? Time difference is equal to 0. So no elapse of time, okay. So that particular displacement is known as virtual displacement. So how you can define virtual displacement? You can define virtual displacement as if there is a infinitesimal change from one allowed configuration to another allowed configuration, okay, at the same time. At the same time means here also t, here also t, such that the time difference or no elapse of time occurs, then the displacement is known as virtual displacement. So you can write the definition as real displacement. I have told you real displacement. Real displacement everybody knows. Real displacement will require time. If it is t, it will be t prime. So it will consume some time and time will increase, okay. But in case of virtual displacement, what we are going to deal with? The same time, okay, same time. If it is here 12:45 and I am displaced to this position, the time is same 12:45. It is not changing. That is the most important point. And you know, when a particle changes its position, it requires some time. But here in this case, the particle is not taking some time. Time is constant. Here also 12:45. Here also 12:45. So time is not changing. So time elapsed or time difference is 0. So there is no elapse of time. Okay. So virtual displacement, you can write the definition as follows. Okay. when a particle undergoes infinitesimal, okay, you can write as very small, okay, very small, so when a particle undergoes infinitesimal change, so very small change from one allowed configuration to another allowed configuration, from one allowed configuration to another allowed configuration, such that time is constant at the same time, okay, you can write as at the same time, that is no elapse of time, okay, no elapse of time. So you can write the definition, no elapse, okay, EL only, single L, no elapse, sorry for this spelling mistake, okay, no elapses of time, okay. So you can understand it if I give a summary. When a particle will undergo a infinitesimal change means very small change from one configuration to another configuration, and the time is same at the same time, okay, at the same time means here I am writing from one allowed configuration to another allowed configuration at the same time, okay. If it is in this position, this is a one allowed configuration, if it is time is t, so one allowed configuration to another allowed configuration, this is another allowed configuration at the same time, so here also time t, so what is the time difference? Is 0, so there is no elapses of time, okay. In this case you will define as the virtual displacement, and it is basically denoted by delta r vector, okay, and you know the position vector will satisfy the constraint equation, okay, that means holonomic constraint equation, and in this case the major issue is it is no longer independent, okay, you cannot take the value as per your choice. So it is virtual displacement. If we talk about the virtual work, what is virtual work? Is nothing like your work dot product of force and displacement, and if you are taking for variable force, integration part is involved, okay. So virtual work is nothing but the force, it is force like your real force dot virtual displacement, okay, this will give you the virtual work. Is it clear or not? Okay, so virtual displacement give rise to virtual work, and this two fundamental thing we are going to deal with in D'Alembert principle. So revise it and wait for the next video. Thank you.